Hello and welcome to another walkthrough. Now this time it will be Edexcel IAL S1 May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. Here's the paper. And I'm going to start the timer and now. Okay, let's go. Number one, I'm gonna do it here on the right side. Number one, we have a table of discrete random variable x has probability distribution here. Find f 3.5. Well, the capital F there indicates that it's cumulative. So you need to add the probability from the very further left, which is x equals 1 here, until it's about 3.5. So it's gonna include 1 and 2 and 3 here. So we just write if 3.5 would be equal to 0.3 plus 0.2 plus 0.35. Not including 4 because that's not less than 3.5. And that should be just 0.85 if you do the math there. B, find P of that. Well, the easiest way to do that is to simplify the inequality here first. So you can make it like if you subtract x on both sides, I get 2x here, less than if you move 2 to the left side, you have, well, you don't need to, maybe move minus 3 to the other side, I have 5 here, right? Okay, and that would be just p of x less than 5 divided by 2 is 2.5. So we're going to find the probability of the things that's the x that is less than 2.5. So that would include the 1 and the 2. Okay, so this would be just 0.3 plus 0.2. It's just this thing is basically the same as f 2.5. That's why you have to add up some probabilities. So it's going to give you 0.5. All right. Okay. So that's the answer for part B. Part C. Find expected value of this. So expected value, you just multiply the, so what's the formula? Expected value is just the sum of products between x and probability of x equals x. So basically just multiply the two rows in each column, and add them up. You should know this, Okay, so it's just 1 times 0.3 plus 2 times 0.2 plus, why did I write? Okay, 3 times 0.35 plus 4 times 0.15. That's the working line, but I'm just going to use a calculator. So 1 times 0.3 plus 2 times 0.2 plus 3 times 0.35 plus 4 times 0.15. Double checking everything. If we plug in everything correctly here, okay, so that's 2.35 here, expected value, so that's fine. Okay, part D, show that var x is that. Well, var x, the definition of variance of a discrete random variable would be the expected value of x squared minus the expected value of x overall squared, like that. It's just the square mean of squares minus the square of mean. Okay. Well, we haven't got the e of x squared yet, right? So we need to find it first. So e of x squared is basically just the square of x. So it's basically just doing the same thing like you did here, but changing from x to x squared. So if this is like some letter h, this would be an h, and multiply that because this is x squared, so we do x squared here. So basically just 1 squared times 0.5 plus 2 squared times 0.2 plus 3 squared times 0.35 plus 4 squared times 0.15. If you add them up, then you get e of x squared. Well, I'm just gonna maybe do that, square, yeah, because you have the 2 there, so just use it, and square. So basically I didn't delete anything, just add the square on each term, and that should be it, 6.65. Well, that means if you want var x, right, it's just going to be 6.65 minus the mean, which is 2.35 squared. Yeah, and that should be the answer to this part. So I'm just going to take 6.65 minus 2.35 squared. That gives me 1.1275. I'm just going to round that to maybe 1.128. Yeah, just some reasonable decimal places. Part E. Find var of that. Well, this is kind of like coding in discrete random variable, like how coding affects the variance and mean. You should know that. So when we have var of ax plus b, is just basically a squared var x. So the b here is negligible. It doesn't change the variance. That means var of 5 minus 2x is going to be, we're just going to take the minus 2 out and square it and put the var x instead here. So we ignore the 5 basically. Note that it's just the coefficient in front of x, right? Not just the first one. Just gotta be careful there. So this is 4 times var x, which was 1.1275. I'm just going to take exact value there. Okay, so I'm just going to equal and multiply that by 4, which gives me, ooh, hang on. Oh, I didn't copy wrong. Okay, 4.51. Yeah, so that's the var of 5 minus 2x. All right, the first one is done. Not too bad, a good warm-up. Number 2. Students in class A and class B sit a statistics test. There are 24 students in class A and 30 students in class B. The marks X for students in each class are summarized in the table below. Okay, so we have the marks and everything. 2 classes are combined into one group of 54 students. The mean mark of all 54 students is 45. Show that B equals that. Well, this is combined mean, so combined mean basically. So I'm just going to do X bar C that. It's just the mean of first group times the number of the first group plus the mean of the second group times the number of the second group divided by the total sum of the numbers of the groups, the students in the groups. So class A, X bar is 47, number is N24. Class B, X2 is B, number is 30. And the sum of the 2 classes would be 54. And the combined mean is given to be 45. Yeah, so we just solve for B basically. So B is just 54 times 45 minus 47 times 24 divided by 30. Just basically solving the algebra there. Yeah. So I'm just going to do fraction. 54 times 45 minus 47 times 24 divided by 30. Yeah, which give me exactly what we want. Okay. And part B. Find the standard deviation of the marks for all 54 students. Well, standard deviation is basically a square root of variance, right? Which is the square root. Well, we have the sum of x squared and mean there. So the best way to do is probably do this, yeah? Sum of x squared in there minus, so variance. This has to be divided by n, yeah? So this is the formula of variance. Mean of squares, so you sum of the squares and divide by n, which gives you the mean of squares, and divide by the x bar squared. Yeah, that's it for the variance. Well, because we have 2 groups, so the sum of x squared would be just the sum of x squareds here from the table and this row, this column, yeah? So we're just going to do 66876 plus 73826 divided by sum of all students, which will be 55, right? That's the number of all students, 2 groups combined. And the mean here would have to be the combined mean, right? Because we are summing the 2 groups now. So the combined mean would be 45 as we used it earlier. So it's minus 45 squared. That's it. That would be the standard deviation. So we plug that in the calculator. Yeah. Hang on. So square root of fraction 66876 plus 73826 divided by 54. Yeah, and then minus 45 squared. So that would be, yeah, that's quite high actually. Oh yeah, probably not because x bar is that. So yeah, that's okay. So about 24 point, I'm just going to put as 1 maybe, 1 decimal place because it doesn't say. So yeah. Okay, so that's it for the standard deviation. Okay, part C, right? Following moderation, each student in class B has their mark increased by 2. Okay? Without further calculation, state giving a reason in each case, the effects this will have on the variance. Well, if you double all the data by 2, of course, variance will be greater. This is like coding. Okay, so y is 2x, right? Let's say you have a variable x representing, the student in class B, and then the y is just 2 times that. Yeah. So that means var y would be 4 times var x, right? I'm not calculating anything. I'm just showing you how it works, right? Increased by 2. Wait, hang on. Increased by 2, not doubled. Okay. Sorry. Increased by 2 would be x plus 2. So yeah, same concept, but now different. Var y would be var x because we ignore the 2, right? Remember last question, I didn't take the 5, so we shouldn't take the 2 here. That means variance on the marks for class B, no change. Do we have to give a reason? Yeah, because increase of 2 doesn't. So it's like this. When you want a reason about why the parameters in statistics like mean and variance and everything, you refer it to a common language. So when you talk about standard deviation or variance, you talk about spreadness of the data. When you talk about mean, you talk about average. So average is a common language. Yeah, mean is a statistical language. So just that, right? So here we say the increase of 2 doesn't affect the spreadness. I'm just going to put here of marks in class B. That's it. Yeah, that's part I. Part II, the mean mark for all 54 students. Well, of course, if all of the marks are increased by 2, then the mean should increase. Yeah. Well, or if you want, I can just show you that the mean of that will also be the mean of x plus 2, just by coding equation that, and the mean is expected value. So because, okay, we just say here increase, yeah, increases, because the mean, well, I'm just going to use common language, because the average mark in class B will increase. Yeah, hence the overall mark, average mark, overall average mark for all 54 students will increase. Yeah, simple, right? Not complicated. And part II, the standard deviation of the marks for all 54 students. Well, again, this is the same logic because, wait, hang on. It might actually. It doesn't affect the variance of the marks in class B itself, but because it affects the mean of the marks in class B, right? So if we look at how we calculated the standard deviation here, this would be higher. But this, the sum of x squared, the mean of squares will also be higher, right? Because sum of x squared would increase. But if you only calculate the standard deviation of the B alone, it won't change, right? It won't change. But when you put it in the context of other group, like group A here, this term will change, right? And this term will also change. Now, how does it change? Well, so because let's look at the mean. So the mean value of the two groups combined is 45, okay? And the mean of B, right, was 43, okay? Now, if you increase every mark in group B by 2, that's going to push the mean to 45.4, right? We just add that class B mean by 2. So it's going to be 45.4. That is even closer to the combined mean of all groups, right? So if it's closer to the combined mean, then that would mean that it's going to reduce the spreadness of the data, yeah? And this is subtle here. This one might be a little harder than the previous two. So it will, standard deviation here will decrease, right, for the third part, because adding by 2 to data in class B would make the mean in B closer to the combined mean, yeah, i.e. 55.4 is about 45 now. So the data, so all data from both class are less spread, yeah, less spread. Therefore, the standard deviation of all 54 students decreases. That's it for number 2. Okay, I'm going to go do number 3 now. Ooh, long one. Huh? Number 3, statistical models are a cheap and quick way to make predictions about real-world situations. A, give one other reason why statistical models are used. One other reason. Predictions about the real-world situation. Well, we don't have to predict, right? We can represent. So we can also use the wait, hang on. This is statistical models. I think it's also a tool to represent rather than predict. So predict is when you use the data to predict maybe outside or predict something that is not in the data. Like for example, if you have a range of integers from 1 to 10, you know that's going to give you some values. But what if it's 2.5? You can use the model to predict, but it's not only about prediction, it's also about representation. Okay, so I think it's also about representation. We can use the model to represent and interpret the data to understand the nature about the situation, because it says situation here, might be about weather or anything, yeah. Medicine wants to develop a model to describe the relationship between an average daily temperature T theta and a household daily gas consumption D in winter. Medicine takes a random sample of 12 days in the winter and codes the daily gas consumption so that W equals 11.5 D. Okay, the data are summarized below. So we have T and W first, so T being temperature and W being 11.5 D. Okay, all right. Okay, so part B show that SWW is that. So SWW, right, is basically a spread here. S, yeah. It's going to be sigma w squared minus sigma w times sigma w divided by n, like that. Yeah? Is it? Yeah, it should be. Yeah. So sigma w squared is that, right? Minus sigma w. I mean, you can open the formula sheet, but you know, I'm not having it right now, so I'm just gonna use my memory. N is 12 days, so yeah, we're gonna see if I got it right on that one. That 0.45, yeah, minus 339.25 squared divided by 12. Okay, yeah, 445.569,791 blah 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 equals 445.57. The two decimal places, of course. Okay. Part C, find the value of STD. Okay, so it's given you STW. You need to find STD, right? Okay. So, well, STW is given to be minus 91.55. But what is STW by its nature? Well, STW is just sum of TW. Yeah, sum of T times W. Like that. Yeah. Minus sum of T times sum of W divided by N. That's what they are, right? But we want STW. So what is STW? Sorry, STD. It's going to be sum of TD and similarly that, right? Now, how do we use the coding equation here? Because we have the relation between W and D, right? So it's like we already know what this is. It's given to be minus 91.55. But to change from W to 11 to D, right? So W equals 11.5 D. Well, that means we can do, if we have W bar, is going to be 11.5 D bar as well. Just coding there. Now, if W bar is 11.5 D bar, that means the sum will also multiply, right? Because when you sum them up, so if we have, so we have the W there, so like W bar is sum of W over N, yeah? So W bar will be, sum of W will be W bar times N. On the other hand, yeah, because W bar, all right, hang on. W bar is also, isn't it? W bar is also 11.5 D bar. Yeah? That means, yeah, that means, okay, let me just think about that. Yeah, so we want D bar, right? We want D bar in there. Okay. Yeah, I think it would just affect the whole thing by just, it would just be, you know, W divided by 11, like the STW divided by 11.5. I think it's going to be that. Yeah. But, you know, well, to prove it, it's going to take a while. Yeah. Yeah. Okay. Yeah, look. Let me explain this way. When you change from W to D, right? Because we know that W is just, well, D, right? D is W divided by 11.5. So instead of W, instead of D down here, you're going to change D to 11 point W divided by 11.5. And imagine all the terms with the D will change to W over 11.5. So this sum will have a multiple of, so it's going to be like this. It's going to be, this whole thing will be all that divided by 11.5. Because you like multiplying all the sums of TD there. So you're going to have a factor of 1 over 11.5 here. And also, because this is also W over 11.5, so it's like sum of t times sum of w times 1 over 11.5 here, and everything else is the same. So I'm just saying that, yeah, to find sum of TD, you basically just do the S of TW divided by 11.5. That's what I'm saying, basically. So that's just minus 91 over 55 divided by 11.5, all right? Yeah. So 91 over, sorry, 0.55 divided by 11.5 there. So that's going to give you minus 7.691, okay, for that. And the other one is SDD. Well, yeah, now SDD, you have two Ds. Yeah, so you see, when you change from 1W to 1W to 1D, it's going to divide by 11.5 once. But when you change two letters from W, because we have SWW from part B, it's going to divide 2 times. It's just like finding coded variance, right? Yeah, so I can also write that var of W is going to be equal to 11.5 squared var of D. That means if you want variance of D, it's going to be variance of W divided by 11.5 squared. That is saying that when you find the spread here, the S is basically just variance times n, so it's no different to variance. The behavior of variance and the behavior of S are the same. They're just different values. So basically S is just variance times n, yeah? That's the definition of variance there. So SDD is just SWW divided by 11.5 squared, yeah? So 445.57 divided by that. 445, isn't it? 0.57 divided by 11.5 squared. So 3.369. I forgot I was speaking English. I was about to speak my own language, sorry. Yeah, so that's the SDD and STD. That's it. Part E. Wait, no, part D first. So part D, hence find the product moment correlation coefficient between D and T. So PMCC of D and T would be, what's the formula again? It's the STD, right? Divided by square root of STT times STD. Yep, I think so. So STD was found earlier, wasn't it? In part C, right? Okay, so STD was minus 7.961 divided by square root of STT, 26.43 times SDD. We got it to be 3.369. So we're just going to find that. Hopefully it's some sensible value there. 7.961 divided by square root of 26.43 times 3.369. Yep, makes sense. Okay, I'm just going to keep it as 3 significant figures here. Okay. And part E. Given interpretation in context of your product moment correlation coefficient, well, this is a negative, so it's a negative correlation, right? Good negative correlation. Well, but that's not actually the interpretation yet. So interpretation would be this is a linear. Okay, wait, hang on. Oh, no, because it's a negative correlation, so this means that as so what will be y, what will be x here? This is TD, so D as a function of T, yeah, because it's TD, so D is the dependent variable and T is the independent. So we say that D, which is the daily gas consumption, so the household, just getting the context there, daily gas consumption, yeah, is, well, linearly decreases when the T, which is the daily temperature, when the average daily temperature increases. Like that. That's how you interpret the PMCC. It's just negative correlation. Okay. F show that the equation of the regression line of W on T is that. Okay. So we need to find B first. Yeah. B, which is the gradient of the regression line. So B is basically SXY in this case, which is STW divided by STT, right? Where is it? Should be, right? STT, which is the X. Okay, yeah. SXY over SXX. Yeah, I think so. So STW minus 91.55 divided by STT, which is 26.43. So let's check the gradient first if we got it right. 26.443. Yeah, looks like we have the right gradient there. So this is minus 3.46. I'm just gonna write maybe some more digit first, up to 9, and then just round that to minus 3.46. And then that's the B. So the A, well, we can just plug into the equation. So the regression line is usually, if in this form, it's going to be W equals BT plus A, right? Because they have B in front there, the B and the T. But in order to find A, yeah, we just find the mean. So the mean of W and the mean of T. And then we make A the subject. Yeah, so A is just, W bar is just 339.25. So that's the sum of W divided by N, which is how many days? 12. And then that would minus, right? The B we got earlier. That's why I didn't take that as a, so I prefer using that rather. So it's going to be minus B, which is minus 3.4639, yeah, times T, which is T bar, which is 9.1 divided by 12, right? And that's going to be A. So we just take that as an answer and clear. So 339.25 divided by 12. And then minus answer times, yeah, 9.1 divided by 12. So that's going to be 30.898. So that's going to be 30 point, they want just 30.9. Okay. So that means the regression would be W equals minus 3.46T plus 30.9 as required. Because we got A and B to be the same values there. Oh, 3 significant figures. Yeah. We got it. Okay, part G. Write down the equation of the regression line of D on T, right? So, of D on T, right? So, because W is 11.5D, so we're just going to plug 11.5D in the W instead. Just going to do 11.5D in the W there, and everything else is just the same, right? Just like this. Yeah, that's the trick there, usually. Like that. Yeah. So we just make D the subject. Yeah. So if you divide 11.5 to every term, 3.46 divided by 11, we get minus 0.315T plus 30.9 divided by 11. Wait, hang on. Did I divide by 3.46 divided by 11.5? Ah, almost. Because I heard myself say 11, not 11.5, so I just got back to that. 0.301T, and there's a minus there. And also 30.9, wait, no, 30.9 divided by 11.5. Okay, that would be 2.669. Yeah, just 3 significant figures. Just, yeah, the same amount of significant figures there. Okay, that's it. Regression line of D on T. In part H, using your equation in part G, part I, estimate the daily gas consumption in winter when the temperature is 2. Okay, so we're just going to plug 2 degrees Celsius in the T, right? It's T in degrees Celsius, yeah. So D equals minus 0.301 times 2 plus 2.69. So whatever that gives me is going to be the answer. Yeah, so 2 point, I'm just going to make it like 2 decimal places here. We don't want to go too far there. So it's just 2.09 cubic meter. Yeah. Okay. The daily gas consumption. Yeah. And part II, interpret the effect of an increase of 1 degree Celsius in average daily temperature is expected to have on the daily gas consumption in winter. Okay. So a change of T by 1, what does it do? Well, we have the regression line model. This is a change of 1. So a change of 1 will lead to a change of D of equal to gradient. Yeah? Because basically if we put, it's like this. You can make the equation look like this. So from that linear regression line model, you have delta T equals minus 3.1 delta T. Delta D equals minus 0.301 delta T. So that means if you plug delta T as 1, an increase, so delta D will be a decrease of, the gradient there. Because that's what the gradient is the change per 1 unit delta X, right? So we say that the daily gas consumption, it will decrease by 0.301, and the unit is cubic meter again. Yeah, and that's it. Yep, and the time is ticking. I think I'm gonna have to go ahead and do number 4 now. Two events C and D are such that blah blah blah. Okay, find PC intersect D. Well, yeah, let's just have a crack on the union and the intersect there. So, okay, we have also the conditional probability. We need to know from Bayes' theorem that this is PC intersect D, which is what we want in the first part here, divided by PD, right? Because it's given D. Okay, and we already know PD. So if we substitute everything, so this is 0.2 and PC intersect D divided by PD, which is given to be 0.445 as well. Yeah, so that means PC intersect D is just multiplying those two. So you should get 0.9, right? No, that's not right, 0.09. Yeah. Yeah, that should be it. Okay. That's the answer to part A. Part B, find PC. Well, I mean, PC union D, you should know this formula is useful. You add up the two separately like that, but you subtract the intersection here. So that's the definition of the union there. If you try to do Venn diagram, you will see that this is exactly the case. C union D is 0.59 equals PC is what we want to find, plus PD is given to be 0.45, and C intersect D we just got to be 0.09, right? So that means PC is just doing the algebra there. We would have 0.95 minus 0.45 plus 0.09, right? Yeah. So that would be 0.23 basically. Okay, that one was quick. Number 5. Let's do number 5, yeah. The following grouped frequency distribution summary summarizes the speeds in kilometers per hour that a random sample 2 to 5 cars were doing on a road. A histogram is drawn to represent these data. The height of the tallest bar is 10 centimeters. Okay, here we go. Calculate the height of the second tallest bar. All right. The tallest bar is 10 centimeter. Okay, so I think we need to find the tallest. So tallest bar, the frequency density. Yeah, we find the frequency density first. So the frequency density is going to be, well, by the looks, it's not just about the highest frequency, it's the highest frequency density, but the class widths of all classes are kind of, well, not exactly the same. Okay, so we probably need to calculate first. Yeah, so this is 54 over 5, this is 90 over 5, this is 60 over 10, this is 15 over 15. Yeah, and this is 6 over 15. Is that right? Yep. Okay, so by the looks from the fraction here, this one is high. What is this one? It's 18, isn't it? 18 times 5, yeah, that's 19. So this is winning. This is just 10, so this one is the greatest one, isn't it? Right? So 19 over 5 is 18. So the height is 10, so that means the height factor, I'm just going to put like that, yeah, so it's going to be 18 over 10. So it's 18 of the frequency, so it's 1.8. For every 1.8 frequency density, you need to plot for 1 centimeter. So it's 1 centimeter to 1.8 frequency density, basically. All right. So the height of the second tallest bar would be the ones that is the second highest frequency density, which I think is this one, right? We got this one. 54 over 5, isn't it? Yeah. So second tallest. So frequency density is 54 over 5. Yeah. So if we want to find the height in centimeters, we got to divide by 1.8, right? Because 18 divided by 10 gives you, wait, hang on. 18 divided by 1.8 gives you 10 to be the height. So this will be, just do a factor there, 54 over 5 divided by 1.8 will give you the height, right? So 54 over 5 times 1.8 down here instead. Okay, so that's going to be 6 centimeters. For the second tallest height, second tallest bar. Okay. Estimate how many of the 225 cars were doing a speed between 35 to 57. You must show your working clearly. 35 is midpoint of this class, right? 57, however, is not exactly midpoint. It's somewhere there. Okay, it's going to be tricky. All right, but we can do that. We can use linear interpolation. So I'm just going to do n of, yeah, n of x. N means number, yeah, between 35 to 55, right? We're going to do 255 first, so we're going to get from this one to that one. Well, let me just separate to 35 to 40 first. So 35 to 40, as you can see, is 35 is midpoint on that class. That means it's going to be half because it's midpoint to the right tail. So it's going to be half that. It starts from the midpoint. So I'm just going to write 30 here. And then we have n of x less than equal 40 to 55. This is basically just 15, right? Yeah, we're going to take the whole class. And the last one, we're going to go from 55. Yeah, hang on. Yeah, 55 and to 57. So how do we do this one? Well, you got to interpolate. So from 55 to 57 is just, you do 57 minus 55 to find the distance there. How you go from 55 to 57. So it's 2 out of how many? 55 to 70 is 15, right? So you get 2 out of 15 of the whole group. This is linear interpolation. I mean, if you went like 60, yeah, if you went from 55 to 60, it would have been 60 minus 55 divided by 15. Okay, but this is just 57, so we subtract to get 2 divided by 15 to find the proportion. Basically, this works as a proportion out of the whole group, which is just 6 cars. Okay, so that's just the number of cars from that part alone. And if we add them up, right? Okay, I can just find that one. So 2 divided by 15 times 6, yeah, that's 0.8. Yeah. So we're just going to do 30 plus 15 plus 0.8, which is 45.8, right? Okay, so how many of the 225 cars? Yeah, we're just gonna round to about 46 cars, yeah? Because that's statistic, not an exact number. All right. 46 cars. Yep, I'm fine. Use linear interpolation to estimate the median speed, yeah? Median, okay, so we have 225 cars. So if we do 225 divided by 2, that's about 112.5, right? 112.5 is in the second group, yeah? So this is the way I go about this. So you have 25 and 30. That's just the, the lower bound and upper bound of the class. And then you want to find the median. So median, let's say, is Q2. It's going to be somewhere there, right? Make sense? Now, you're going to write the cumulative frequency on the lower bound here, below the lower bound, and you'll see what I mean. And the cumulative frequency of the like 54 plus 90 here for the upper bound. So this is for the lower bound 54 because it's the beginning of this class. But when you add 90 more, it's going to be the end of this class, right? So it's going to be 144 there. It's just the way that it will make the formula here easier. It's easier to memorize like this. You don't need to memorize any formula. So we know that the median will occur at 112.5. That's where the median is, right? So you're going to do that distance divided by that distance equals that distance divided by that distance. You got it? Yeah? So that distance is just Q2 minus 25, right? Because we want to find the distance between the two numbers. And then this distance would just be 30 minus 25, which is 5, right? And now this shorter distance as well, which is 112.5 minus 45, divided by this distance, which is, and this is going to be 90. It's going to be the frequency of that class, basically. Okay? And now we solve for Q2. So it's going to be fraction 112.5, 112.5. I got to be really careful with the thing I put in the calculator here. Yeah. Well, yeah. Sorry. Over 90. Multiply by 5 first, because you move 5 first, and then you plus 25, yeah, when you solve this equation. So that's going to be 28.25, which makes sense because you expect it to be in between 25 and 30. If you don't get that, then something is wrong. You double check, right? Yeah, so that's the median for part C. Part D. The lower quartile for these data is that, for significant figures, D find an estimate for the upper quartile. Okay, the upper quartile, right? Okay. Lower quartile is that. Okay, so we just find the upper quartile, which will be, the location is then 225 divided by, it's going to be 3 over 4 times 225, basically, yeah, when you find the location of that. So that's going to be what? 225 times 3 divided by 4. It's going to be 168.75. That's a horrible number, okay? So where is it in the class? This is 144. If you add 144 to that, you get, it's going to still be this class. Yeah. So we need to do interpolation again. Is this, oh, it's not this class, it's this class instead. 168 is in this class, right? If you add up the frequency, you will find that the cumulative frequency on this class is greater than 168.75. That's the upper quartile. Okay, never mind. So we're just going to do the same thing, but different class here. 30, 40, and this is Q3 now, right? And then you would have the cumulative from the lower bound there is 144, and cumulative for the upper bound is 204, right? Just add by 60. So this is again 168.75. Again, the shorter one on the top, Q3 minus 30, divided by the longer one, like the long one is 10, right? Just 40 minus 3 equals 168.75 minus 144 divided by just distance between 144 to 204, which is 60. So Q3 is going to be, just do that math, fraction 168.75 minus 144 divided by 60 times 10 and then plus 30, right? Just like that. So it's 34.125, yeah? Okay, so that's the Q3, which is the upper quartile, the 4 significant figures. So I'm just going to do 34.213. And then part II, we need to also find the interquartile range. So IQR is just basically Q3 minus Q1. So it's just, it doesn't say, yeah, okay, hang on. So this is 34.13 minus 25.14. Yeah, that's fine, that's fine. 34.13 minus 25.14. So we're just going to do 8.99. Yeah, like that. Okay, that's the interquartile range in DII part E. Let me check the calculator again. I mean, should be fine. Yep. Part E. Describe, giving a reason, the skewness of these data. Well, typically you compare the mean and the median. So the mean was, what is the mean? Do we get the mean here? Well, we know the median, right? Okay, we haven't got the mean, have we? Oh, no, we can use, yeah, we can use distances between, okay. So we calculate Q3 minus Q1. No, Q3 minus Q2 is going to be 34.13 minus Q2 was median, right? It was 28.25. Okay? And that's going to be 5.88. And then we do another one, Q2 minus Q1. And we can compare which one is greater and comment on the skewness correspondingly. So this is 28.25 again minus the Q1, which was 25.14, right? It was given there. Yeah. So this is 3.11. Well, it is obvious that Q3, so Q3 minus Q2 is greater than Q2 minus Q1, right? So basically it's going to look like this. If you change this to a whisker plot, Q3 minus Q2 is of a greater distance compared to Q2 minus Q1. So it's going to be skewed to the right because you have more data here, right? You have, like, it's extended like that. So this is positive skew. Yeah, positive skew. Positive skewness. Right? And the reason is just this. You can use that as the reason as well. Okay? Apart from mean and median, right? So if mean greater than median, also positive skew. Ali suggests that the normal distribution is a suitable model for the speed that cars were doing on this road. With reference to your answer in part E, comment on this. Well, yeah, if we want to use skewness, because data is skewed, usually normal distribution should be symmetrical. Yeah? Since part E suggests that data skewed, therefore not symmetrical. Yeah, and any data with skewness, it means it's not symmetrical. Just going to move this to the new line. Well, therefore not suitable, because to be suitable for normal distribution, you need symmetrical data. Yeah. Okay. Right. Yeah, should be symmetrical, but it's not, so it's not suitable. Comment on Ali's suggestion. So suggestion is not reliable. I'm just going to comment on that. Okay. Number 6, part A. Company produces small bags of flour and large bags of flour. The weight X grams of flour in small bag is normally distributed with the mean of that, standard deviation of that. One of the bags of flour, yeah, is selected at random. Part A, I use standardization. Well, yeah, it's just normal distribution. Find P of X greater than 508. Okay, so basically we draw a little bell curve here. The mean is 502, so that's a little more than the mean. So we want this area here, yeah. Okay, so Z would be, we will find the Z first, 508 minus the mean, which is 502, divided by the standard deviation, which is 3. So that is basically 2, right? Okay, 6 divided by 3 is 2. So we just want to find the probability of X greater than 508. That would be 1 minus the probability of P less than equal 508. But we just found the standardized score there. So this is just P of Z. This is X. Less than equal 2. So we just open up the table. Okay. So if we just open up the table, I need to open the formula sheet finally, right? I need to, hang on, give me some time. I forgot to have the formula sheet ready. Where is the formula sheet? Okay, I think I got it. No problem. Hang on, just one sec. Okay, and I'm gonna open the formula sheet so that you guys can see too. Not that one. Okay, here we go. So if we go to the normal distribution table, we're gonna look at when Z equals 2, which is this guy here, yeah. So that's the probability there. So we write 1 minus 0.9772. Okay, I'm gonna close the table. So that's just gonna be 0.0228, right? Yeah, the probability of that. And that is done for the part II, part II, hence find that. Okay, so probability of 496 less than X less than 508 would be equal to the probability of X less than 508 minus the probability of X less than 496. Now, let's take some notice here, because I just noticed that because the mean is 502 and that was 508, right? The first one. Well, the other one is 496. Well, isn't that just the same distance as the other one? So this is distance of 6, this is also 6, right? That means these two probability are the same. That means in the middle, symmetrical. You can just find one of them like this and multiply by 2. Or you can do 1 minus 2 times each one of these, yeah. So I'm just going to do 1 minus, yeah, maybe. So 1 minus 2 times each of these guys, yeah, which is 2 times the 0.0228, right? Okay, so 1 minus 0.0228 times 2. Okay, so that should be the answer to this part. Let me just double check the entry there. Okay, so that's the probability of this part here, part B. A random sample of 4 small bags of flour is taken. Find the probability that exactly 2 of these small bags each contain more than. Okay, so binomial, right? So we're just going to do x, just going to do y now because they already used x. Binomial, 4 small bags. This is S2, sorry. This is S1. I mean, this paper is S1, I'm using S2. No. Exactly 2 of these small bags each contain more than, yeah. So we're just going to do, because 2 bags out of 4 you can have, so I'm going to have yes and no, yeah? Yes represent contains 2 bags, yeah? Contains more than 508 grams of flour. So if we want exactly 2 bags, we can have y prime. So y prime means not containing more than 508 grams. And then you can have variation here. So the variation will just be C4, C2. That's the binomial coefficient. So the number of ways you can vary between the types here, because the next one I can have y bar, y bar, right? Y prime. And there are more, but the quickest way to find how many ways you can alternate these would be just do the 4C2, would be 4 times 3 divided by 2 factorial here, which is 6. So there are 6 ways you can do this. So we're going to do 6 times, right? And exactly 2, so we find each one, exactly 2 of these bags containing more than that would just be the probability of, x more than 508 to the power of 2, because there's 2 bags that with more than that. And the other one is just 1 minus, because we want greater, yeah? We want smaller in this case. And another 2. So that's it. That will be just everything. So we do 6 times the probability of contain more than 508 grams would be 0.0228 to the power of 2. And we multiply by 1 minus 0.0228 to the power of 2, because that's the opposite, yeah? And that should be the answer, 0.00298. I'm just going to keep 3 significant figures there, yeah? Okay. And then part C, what is it? The weight of y grams of flour in large bag is normally distributed again. Okay. The 85th percentile of the weight of the flour in the large bag is that. 85th percentile, you need to interpret that it is around here. That means this area is 15% or 0.15, and the rest is 0.85, which is what it is. So we show that the sigma is 14. All right. So if we look at the table, we're going to find the z value that corresponds to the right tail having an area of 0.15 first. So if we look at the table, we should look at the small one, which is the percentage points of normal distribution here. We happen to have that the probability of the right tail, which is this guy here, being 0.15 corresponds to the z value of that. Yeah, so I just say P of, z greater than, this is 1.0364, is just exactly 0.15. So we're going to use this z value, right? Okay, let's get back to the paper. So that means if we do the equation there to find the, sigma, so z, which is 1.0364, equals the 35th percentile is that, so 1038.15 minus the mean, yeah, which is 1024 divided by sigma, which is what we are finding, standard deviation. So sigma is just equal to, solving that equation there, so fraction 1038.51 minus 1024 divided by 1.0364. So that's 14-ish. So equal 14, yeah, to the nearest gram. All right, so that's as required. Part D. Given that P of x greater than K is equal to P of y less than 2k equals P, where k and P are constant. All right, so this is the same distribution, right? This is the same distribution. This is, wait, x is small bag, right? Okay. That's tricky. Okay, so we want to find P of x greater than k equal to P of y less than 2k. Okay. So it's going to be something like, I don't know, maybe I'm just going to make k around here, yeah? Which is assumingly greater than the mean of the small bag, 502. Yeah, so that's k there. So greater than k is this. Yeah, this is P. And the large bag, right, which has the mean of 1024. So 2k is probably greater than that. So we're going to assume that it's going to be like that, 2k. Oh, hang on. Then it should be around here, I think. Yeah, 2k less than y, so it's this area. I see. So the only way this makes sense is for the small bag to be on the right tail and the large bag to be on the left tail. Or the other way around. It could be the other way around. Could it be the other way around? K? No, probably not. It should be this way around. Because if you had this will even go smaller, which is probably not possible, right? So it should be that. Now, the probability are equal. Okay. So we want to find the value of k. Okay, so this will lead to a value z maybe, and this will lead to a value minus z. Okay? So if we do the z value of the x1, so the z value here is k minus 502 divided by the standard deviation of the small bag, which is 3. Yeah? Okay? And now this one, minus z, right? So it's just minus. Okay, I'm just going to do 2k, yeah, minus the mean, which is 1024, divided by the standard deviation, which is what we got earlier, 14. Yeah, this is the set of this case, the large bag case. Because this set is the negative of this, we can make an equation. Yeah, so we can do k minus 502 divided by 3 equals minus 2k minus 1000 over 2 divided by 14, like this. And we solve this equation, we are home free. Yeah. So you need to interpret the data first. Yeah. So I'm going to have 14k here on the left minus, that's 14 times 503, so 7042. Yeah. Equals, well, that's going to be minus 6k, right? If you multiply 3 and minus 2. And also minus, so that's going to be plus, so it's 1024 times 3, so that's going to be a plus 3072. Okay, so it's 20k equals, well, you add that with 7042, so you get 10,114 there, and we divide the answer by 20. We should get 505.7. Does that make sense? That is greater than this. This is the area. And if you multiply this by 2, you still get somewhere less than 1024. That should make sense. Yeah, I'm happy with that. So we found the k for part I. That's good. So part I, we find the value of p. So we just plug back to the small bag case, maybe. Yeah, so z equals, we just plug that back in. And then find the z value and get the probability basically, right? So equal fraction answer minus 502 divided by 3. Yeah, so that's 1.233. And then we're going to use the table. So P of z, so the probability, right? P, which is greater than k, so P is equal to 1 minus P of z less than 1.233. Okay, so if we look at the table, Let me show the table again. 1.23. Yeah, we're going to round that to 1.23. So we're just going to pick this guy right here, 1.23, 0.8907. 1 minus 0.8907. Maybe I'm just going to have to round that to this. Yeah, and that's going to be 1 minus 0.8907. Yeah, 0.1093. I'm just going to round that to 0.109. Yeah, that's the value of P then. Is that right? Yeah. Okay. Okay, cool. So that's done. Oh, we still have some more to do. 7? Oh, just 7 questions. All right, we're on the last one now. Good, good, good. Okay. Riley has a bag containing 3 white beads and 6 yellow beads only. 2 beads are selected at random from the bag, 1 at a time without replacement. Okay. Complete the tree diagram on page 21. Okay, page 21 here. Okay, so 3 whites and 6 yellows. So white would be 3 out of 12, right? Because, no, 9. Come on. Yeah, 3 out of 9. So the first yellow would be 6 out of 9 as well. Yeah. Now, if you already taken out 1 bead without replacing it back into the bag, then you have less beads. So that would be over 8, over 8, all of them over 8, like that. Yeah? I should just move this down more proper. Like that, okay? But then for the second white, because you already take 1 white out, so you have only 2 white left. Yeah? From 3, you now have 2. And for the yellow, because you haven't taken out any yellow on the first pick, then you would have 6, right, on that one. Yeah. Again, similarly, this is you're going to take yellow first and then white. So white hasn't been taken out. So you have 3 white out of 8. Yeah. And again, yellow here, you already took 1 out. So it's just 5 left out of 8. Just that. All right. And B, we will find the probability that exactly one of the beads selected is yellow. Show your working. Well, it's easier when we see at least 1 yellow or at least 1 anything. It's easier to do 1 minus P of no yellow. Yeah, because there might be a lot of ways to get more than 1 of something. It's like 1 yellow and 2 yellows. Yeah. So if I have 1 minus no yellow, that would just be white and white. Yeah, so we get this branch and subtract from 1. So that would be 1 minus. Well, to get a branch, you just multiply it's a compound probability. So you do 3 over 9 times 2 over 8 to get 2 whites. All right, so that's basically 1 minus. That's 1 over 5, 1 over 3 times 1 over 4. So that's 1 over 12, right? So it's 11 over 12 for part B. Part C. Wait, hang on. Oh, what? Why did I read at least? This is exactly one of the beads is yellow. Sorry about that. No, this is the whole thing is wrong. Because I thought it was at least. So P, 1 bead equals yellow. So how do we get that? It's just white, yellow, and yellow, white, right? So that's going to be 3 over 9 times 6 over 8 plus 6 over 9 times 3 over 8. White, yellow, and yellow or white. Okay, so what is that? Just calculator. 1 over 3, which is 3 over 9, times 6 over 8 plus 6 over 9 times 3 over 8, right? Yep, so that's 1 over 2. Okay. Yeah, almost got that wrong. Okay. Part C, find the probability that at least one of the beads selected is white. Oh, wait, hang on. So I was reading part C and thought it was part B. Okay. So again, P of at least one of the bead is white, right? That would be equal to 1 minus P of no white. right? Yeah, just the same method there, just different color actually. So 1 minus no white would be all yellow, like this. So 6 over 9 times 5 over 8, yeah, so just that. 1 minus 6 over 9 times 5 over 8, yeah? Wait, hang on, over 8 like this. Ooh, why don't it gives me, wait, hang on, I plucked the wrong thing. Like that, yeah, it should be like that. So this is 7 over 12. Instead, Riley adds some beads to the bag, so it contains a total number of n beads. The beads are either red or yellow or white, such that number of red beads, number of yellow beads, and number of white beads 4 to 3 to 1. Okay, 4 beads are selected at random from the bag, one at a time without replacement. The probability of getting 2 red beads followed by a yellow bead followed by a white bead. So this is in order. You can't swap the thing. Yeah. So show that n satisfy the equation. And that's it, right? So that's the end of the paper. Okay. We are not asked to find anything there. All right. So the total is n beads, and then you have 4 to 3 to 1, right? So we write red to yellow to white. Hi guys, just a quick one here. This statistics always blows my mind. So as you can see, for the past 28 days as of today, 90% of those watch hours come from those of you who aren't subscribed to my channel. And that gives me an urge to beg you, please help support me by subscribing the channel. I will return this huge favor by creating more and more videos. I'm going to utilize my teaching experience for 10 plus years to create the videos covering tips and tricks and the hard bits in the topics that most students struggle to understand. It can either be a short video, a long video, but they will sure come up. So that is why you need to subscribe to stay tuned. I hope we have a deal. Let's get back to the walkthrough. So the fractions here is, there are 8 units, yeah? So this is 4 over 8, this is 3 over 8, this is 1 over 8. Okay? And you can put n in there, yeah, because the total beads is n. Yeah, you're going to select 4 beads at random. We want probability of getting 2 red beads first, so 2 red bead first would be, what's the red bead? It's this is 1 over 2n, right? So 1 over 2, just going to do n over 2 here, the probability of red beads. That's the number of red beads, right? Yeah. Okay, so out of n, that's the probability of 1 red bead, right? It's just number of red beads divided by the total number. Times, well, you already take out 1 bead, so you need to subtract 1. This is another red bead, divided by n minus 1. Remember, this is, if it doesn't say that n is a large number, you need to subtract 1 because you don't replace, right? You need to subtract 1. Now, those are 2 red beads already in order, yeah? Followed by a yellow bead, so we're going to have 3 over 8 because the yellow bead hasn't been taken out. That's going to be the number of yellow beads on the first pick. And then now, because you already taken out 2 beads, so it's going to be n minus 2. And the last one here is 1 over 8n. This is followed by the last one being yellow. So yellow is that, divided by n minus 3. That's horrible. And then we have 3 over 235, right? Okay, so can we simplify all this? That's horrible. Algebra. I mean, I was wondering if we actually can simplify a little bit. Okay, that's fine, I guess. Okay, I think at least we can cancel this and that, of course. And this is going to be cubic, right? Yeah, okay. Okay. All right, so let me just have a crack on this. If I, yeah, probably have to multiply them out, right? So this is basically that, multiply that, and all this will be moved to the other side. How about that, yeah? So we're just going to do 235 from the right side, divide by 2, and this is 2n over 2 minus 1. That's half, right? Yeah. times 3 over 8n times n over 8 equals, and then on the right side we have a 3, n minus 1, n minus 2, and n minus 3, like that. Yeah? So let's simplify that, can we not? How are we going to do that? That's going to be horrible. I mean, I'm not sure if we're going to get this, but I'm just going to try anyway. Yeah. Let's see what we get there. Well, it seems like I should multiply the whole thing by, that's going to be horrible. So if I multiply this by 5, I get 47. That's a horrible number. One at a time without replacement. That should be it. The theory should be right. We're just going to multiply everything, right? So let me multiply by the lowest common multiple, which is 8 times 8 times 2 times 2. Basically just multiply everything. Okay, so if we multiply all that, yeah? If we multiply 2 to this first, we're going to get n minus 2, right? Multiply 2 to that. I mean, I'm going to multiply by 2 times 2 times 8 times 8 to both sides. But I can selectively multiply 2 to a particular bracket. So I'm multiplying 2 to this one, I get n minus 2. I'm multiplying 8 to this one, I get 3n. I'm multiplying 8 to this one, I get n. Yeah, 2 times, and 2 to this one, I get 235. And then you're going to multiply to this one as well. Wait, hang on. Yeah, that's fine. So multiply 2 to that one, you get n minus 2. It cancels the other side. So this one, 4 times 8 times 8 is 256 times 3 on the other side, right? Because basically 2 times 2 times 8 times 8 is 256. So you multiply that on the other side too. And then you see that n minus 2 cancel here. That's good. So we have here 3n squared. Wait, okay. So I'm just going to multiply 235 times 3. So I get 705. So this is 705. This one cancel. Right? N squared equals. So is that also 705? 256 times 3? No, it's not. It's 768. And then you multiply n minus 1 and n minus 3. So you're going to get n squared minus 4n plus 3. That is getting close now. So we just expand that. What is that? Multiply 4. Yeah. So it's minus 3072 plus that multiply 3. We get that, right? Yeah, so that, wait, hang on. So that's going to give me, if I move everything to the right side, that's going to be 53. No, 63. Ah, okay. That works, that works. Yep. This is an n. And then if we simplify everything by 3, right? This should be 21n squared. And the 30 and 72 divided by 3, yep. That's 1024n. And the last one, 2304 divided by 3, yep. That's 768 equals 0. So that's it. So b and n are integers, which can be negative. So that's it, guys. I think I'm done with everything. And I'm going to mark the paper and come back in a minute. Yeah, see you in a bit. Okay, guys, I've marked the paper. I think I did nail the paper. Yeah, so I marked the paper based on one of the smartest AI model, Gemini 2.5 Pro. It should do a good job. I have used it many times and it works mostly. Although it makes also some silly mistake, but I corrected it and verified it already. So yeah, I mean, as the time of recording, the official mark scheme isn't out yet, so this is just my personal review with the help of AI. It should be fine. I just marked the paper after I walked through the paper, yeah? And everything is good. So we're going to do a review on each question. This paper, I think, is hard because I got told by many students that I teach at the time that it was so hard, harder than any other paper. They told me that, all right. So I'm gonna believe them because my perspective is different from theirs. So I think it's also hard. The first one is easy, so I'm not gonna review anything on this. Though be careful about part B because sometimes you can get part B wrong if you're not prepared. Part E should be fine. Yeah. This one, yeah, might already be confusing from the first part because you need to know the concept of combined mean, right? How do you combine the values of mean from two groups to be one single group? And part C is, though typical, but some students still get it wrong. Like, how do you interpret the effects if you change anything in the data? Just remember the two keywords. Mean, it's about individual data. If you increase the values of many things in the group, then you increase the mean. But standard deviation and variance alike, they depend on the spread of the data. So if you change the spread, you change the standard deviation and the variance. So how do you increase the spread? You make data further apart, more scattered, more spread. If you somehow can reduce the spread of the data, then the variance and standard deviation will decrease. So yeah, the first part is unchanged. The second part, because you increase the students in class B by 2 individually, you increase the mean by 2. Because you increase the mean of class B, so that gets closer to the mean of class A, right? Or closer to the combined mean, right? So, I mean, at first class B has a mean of 43, right? And when you when you increase that by 2, it gets to be 45.4. So I'm just saying that when you increase by 2, this will be closer to the mean of class A. So when the two groups are closer to each other, the standard deviation decreases. Basically just that. Okay, so that's the number 2 there. This one also tricky. This one is also tricky because it plays with the coding a bit. It's not like it's never done this before. No, it has done this before. But you just have to know that how you change from one S to another S using coding. It's just like variance, as I already mentioned in the walkthrough. So when you code from SWW to STT or STW to STD, how does it change? Yeah, you need to know that. And other questions are fine. Make sure you understand the quickest way to go from one coding linear regression equation to another. Yeah, so the way I did part G there, you should go and check again, right? If you didn't understand. And usually this can come out like asking about the change, right, from the regression line model. Yeah. So overall, this is okay. It's not easy. It's not hard. Could have been harder. There was one paper that gives you information, and like you have to do a lot of algebra and equations and solving to get some variables and find the other. This is easier, I would say. Yeah. Okay, so it's not, it could have been worse, right? Could have been worse. Number 4, yeah, this is easy, straightforward, just like question 1 is easy, like question 1, nothing particularly hard here. So just know that this is the conditional probability, and this is a general formula you should know. If you don't, try learn this, yeah, or memorize actually. I mean, if you try shade in the Venn diagram, that makes sense. If you have C union B, you just add up the two circles. But when you add up the two circles, you're getting one extra bit, so you take it out, which is the third part here that you need to take out. So that becomes the union of C and D. Yeah, this one not too bad. This one not too bad. It's still okay. It's still typical. It's just, yeah, maybe the tricky bit is the first one, because it doesn't normally do this. But you need to know that to go from a frequency table to a histogram bar, you need to do frequency density only. But frequency density, yeah, as we found here, it was 18 for the tallest one. But the height is actually 10, so there is a factor that they can also do here. But the factor for the height will be the same for all other bars. It's like you are drawing the graph, but you don't want to do like you don't want to do 18 centimeters. So you just go like, okay, I'm just going to make this 10 centimeters. So the scale factor is just 1.8, right? When you draw the bars, right? So the second tallest, you just pick the second highest frequency density and calculate the actual height using the same scale factor. And yeah, this is a lot of interpolation here in this question, so make sure you understand how I did it here, like the short divided by long, short divided by long. That's convenient. I don't have to memorize any formula here, so I suggest you maybe try that too. Yeah, and need to know about the skewness, right? So you don't need to do mean or median. You don't need to compare just these two. There are also the ways you can compare the distance between the third and the second quartiles and the distance between the second and the first quartiles. So if this one is greater, then it's going to be, you know, skewed to the right, which is positively skewed. Yeah. If it's the other way around, where the second and the first is longer, then it's negatively skewed. You should know that too. Yeah, this one, I would say the last part here is tricky. You need some thinking a bit. But I think other ones are fine, right? Other ones are fine. Yeah, this one is just find the probability of exactly two bags greater than 508. So the first part should be fine. Every one of you should be able to do it if you're okay with normal distribution. The second one starts being tricky here. You just have to also, you know, not only do you do this, right? This would be just one case, but there are 6 cases that you can do. So that's why you need to multiply by 6. And the only way, I mean, you can run all the cases, but that's going to waste time. You don't want to waste valuable time. You need to know how to get the number of cases quickly. It's just the binomial coefficient. So if you have 4 of them and you want just 2 of them being one case, yeah, it's just C4, C2 there. So there will be 6 cases here. Yeah, 2 of them being y prime and the other 2, of course, being y. Then you would have this. And this one is a highlight here for this paper, I think. It does this before, I remember, in 1 or 2 times. I don't remember, but I remember it does this before in the past paper. And it gives you the relationship between areas. But the hard bit, the critical bit that you need to be able to crack here is it's going to be only on the right tail of the smaller bag and the left tail of the larger bag. Because if it's the other way around, it doesn't make sense. You would have, if K was here, right, then you would have an area of here being P. But then if K was less than 502, it's going to be even further to the left. And that's even further area here, which doesn't match this one. Okay, so make sure you understand that logic, because it's the very key to this kind of question. And not only that, you need to know how to proceed, because then you understand that when the area of the tails are the same, but one is left, one is right, so the Z value are opposite directions, opposite signs. And you get the K and you get the P. The rest is easy. Just plug back into the equation. Number 7 is also tricky, particularly the last one. I would say the first ones are fine. All the first ones are fine, right? But the last one here, the key is you have to remember that if it doesn't say large beats, large number of beats, then you have to do -1, I'm afraid. That's why I do -1, -1, -1, -1, -1 here, right? Keep doing -1 there, because you get less and less beats to pick from. And it intrigues me at first, this whole equation, but when you try simplify it, you will get there. So the way I did that was I multiply all the denominators by this. So I see this that can cancel the other side. So that simplifies a lot. And you just get quadratic there, which is this. All right. And that should all work. That should all be correct. Yeah, I believe. So that was it. So if you've watched this far, I think you find the video useful. Why don't give me a subscribe? And do check other videos in the IAL series. And I hope to see you in the next one. Bye.